Okay, now we're going to talk about lines that intersect either inside the circle or outside the circle. Okay, these lines intersect outside the circle. So first of all, I made this a separate video because all these formulas are going to have something in common. You're going to be multiplying two things. Something times something is going to be equal to something times something 100% of the time. Okay? You're going to multiply two things and make it equal to multiply two things. Alright, so these are called chords, and when they intersect inside the circle, there are two lines that end at the circle. I don't really care that you know that very much. Okay, so this and this, when they intersect in the circle like that, the pieces that are on the same segment get multiplied together. So this one's going to be 3 times 6. And then on your other line, or segment I should say, you've got these two are going to be multiplied together. Alright, so here we go. This is going to be x times 4, or 4 times x, is equal to 3 times 6. 3 times 6. So I'm going to do 4x equals 18. Okay. So I'm multiplying these two. Okay, and then I'm dividing by 4. 4.5. And again, I should be looking at my picture and making sure that this makes sense. Okay, so here, yeah, that seems a little long, but I didn't make up this worksheet, so I don't know how much effort somebody put into that here. You know, this 6 looks like more than twice this one, so I don't think it's very much to scale. Okay, so how about these? Now, again, because I'm using somebody else's worksheet, I would have written this the other way, because whenever lines intersect where you have a piece inside and a piece outside, okay, this one, same thing, piece inside, piece outside, you're going to do what I call whopping, and that stands for whole times outer part. Now, the person that made this worksheet wrote it the other way. Okay, but when I say whop, that's what I'm talking about. Whole times outer part. Multiplication is commutative, so it doesn't matter if it's written like that or like that. Okay? So, whenever you have an inside-outside piece, you have to whop it. So what do I mean by whole and outer part? The whole, let me use this here, the whole is going to be the distance from the furthest point of where they touch the circle to where they intersect each other. So this whole times, and then the outer part is going to be right here. And then on your other side, you're going to do the same thing. Whole times outer part. So what's that going to be on this side? What is the whole going to be here? So if this is 8 and this is 4, 8 plus 4 is 12. And I've done this before with other problem solving. If you're somebody that tends to substitute the wrong things in, scribble out the inside so you make sure that you're using the whole and the outer part, because that's the only thing going into this equation. Alright, on the other side, what's the whole? People say 3x a lot, but we get 12 by adding. 3x is multiplying, so x plus 3, whatever that is, times the outer part. Alright, so let's set that up. So whole, I'm going to slide this up. Whole is x plus 3 times outer part equals whole times outer part. Okay, now this is probably why this teacher put them this way, because it makes more sense. You need parentheses here, by the way, because it's that whatever you get for that whole thing. If you put this on the other side, it makes more sense to students, but it doesn't matter. All you're doing, it's the same. Remember, we just said that multiplication is commutative, so you're just distributing the 3 through. 3 times x plus 3 times 3 is 9. Multiply there. Okay, we're solving now. We're done simplifying, so we need to get our 9 to the other side, so our x is alone. Okay, so 48 minus 9, 39. So I have, I'm going to move it up here now, 3x, and then equals, because I made that 0, that's on the other side, 39. And now I'm just going to The opposite of multiplication is division. So x equals 13. I divide by 3. I can check that. Let's see, 13, 16 times 3. So 16 times 3 and 12 times 4. Yep. Okay, so I like what I did there. Alright, on this one, so this has something in common. You have an inside-outside, so we're still whopping. So it's going to be whole for that times outer part. So what is the whole? The whole is going to be found by adding these. So x plus 5. And again, I'm not going to use that inside part anymore, so I might scribble it out. So whole times outer part. Alright, now this one's all by itself. So this is a tangent line intersecting a secant. When I look up here, I've got to be multiplying two things. So I have my whole times outer part on the one side, so what do I do with that tangent? It's all by itself, so what you do is multiply by itself, 10 times 10, or 10 squared. So we're going to do whole, so x plus 5, I need parentheses, whatever that is, x plus 5 times the outer part equals, and then for this one, again, if it's the only number I have on that, we're just going to square it, 10 times 10, or 10 squared. So I'm going to distribute to get rid of my parentheses. I always have to simplify before I start doing algebra. Okay, now I'm ready to do algebra and balance this equation. Right, I realized you couldn't see that, so I'm distributing 5 times x is 5x plus 25 and 100. Okay, so now I want to get x1, so I'm going to subtract 25. And the opposite of multiplication, it's going to give me 1x, or just x, is divide. So I'm going to get 15. X equals 15. So again, I come up here and I'm like, okay, 15 plus 5, that's going to be 20. So 20 times 5 is 100, and 10 squared is 100. So I feel good about my answer.